everybody. Today I'm going to show you how we calculate acceleration using the acceleration formula. Now remember, acceleration is the rate, that means time in the denominator, of change in velocity. And a change in velocity is always the final velocity minus the initial velocity. Okay? So, we're going to use that to do these two examples. Once you've seen how to do those, then you can do the 5 below fairly easily using all 3 steps, and you must show all 3 steps in order to receive full credit for this assignment. So, here we go. The first example says, a car is stopped at a red light and the driver sees the light turn green. He accelerates the car forward for 10 seconds, at which time the car is now traveling 20 meters per second. Determine the acceleration of the car. All right, step 1 is to identify everything you know. First the numbers and then the inferred information, because there might be some. We'll look at that. The first number I see in this is 10 seconds. Well, we know seconds is a measure of time. So T equals 10 seconds. And we have now identified the time. Oh, the clock. All right, there we go. Now, the other number I see right here is 20 meters per second. Now, we know meters per second is a measure of speed or magnitude of velocity. So, if the car is now traveling at 20 meters per second and it wasn't before, then this must be the final velocity. So, let's identify it. V sub F. F for final, V for velocity. Okay, and that's 20 meters per second. Oops, that looks like a 6, not a 0. There we go. How's that? In fact, let me put some more paper under here because this table has a squishy cloth on it. Okay, that might be better. All right, so now we've identified the numerical given information, but is there any inferred information? Well, look at what it says. A car is stopped at the red light when he sees the light turn green and then accelerates. So he's starting from a 0 velocity, isn't he? He was stopped. He's starting from rest. So we can say the initial velocity, V sub I, you could also use an O for original, V sub O for original, but we'll just use V sub I for initial, is 0. Okay? And what are we trying to find? The acceleration. And notice, 1, 2, 3, 4, 1, 2, 3, 4. So we can do this. Let's write out the formula. A equals VF, always the final first, minus the initial second. And then 10, T for time, 10. Blech. Okay, well it is 10, but we'll put that in a minute. Now let's plug in the numbers. VF is 20 meters per second minus 0 over 10 seconds. Okay? Now, 20 minus 0 is just 20, so basically we're getting 20 over 10 meters per second, okay, because time is in seconds. We can basically cancel out the zeros. That leaves 2 divided by 1. Anything divided by 1 is itself. So the answer, and let's put it back down here, the answer is going to be 2 meters per second squared, because that's the units for acceleration. Remember, velocity is meters per second, but rate of change in velocity is meters per second square. Don't forget that. If there's a square there, it's acceleration. If there's not, it's velocity. Okay? That's how you know. All right, so there's the answer to that one. Now let's look at the second example. It says a train is approaching the terminal at a speed of 10 meters per second when the driver pulls the brake to slow to a stop beside the platform. It takes 20 seconds. Determine the deceleration of the car. Okay, let's look at the numbers that we have. It says the train is approaching the terminal at a speed of 10 meters per second. Now remember, speed is the magnitude of the velocity. It's the numerical value of the velocity. Since this is what the train is doing at the beginning of the problem, then this must be the initial velocity. So we write it down as the initial, 10 meters per second. It says then that it's going to take, he pulls the brake, slows to a stop, it takes 20 seconds. 20 seconds, that's going to be the time. So you slow down for 20 seconds. Now, those are the only two numbers I see, but I want you to notice, it says he pulls the brake and slows to a stop. So at the end of the time period, he is not moving anymore at all. That means his final velocity or final speed is 0 meters per second. Okay? He has none. He's stopped. Okay. What are we trying to find? We're trying to find the deceleration, which is just the acceleration. But because they're slowing down, we know it's pointing opposite the velocity to slow the train down. So let's take a look. We're going to use the formula A equals V sub F minus V sub I over T. So now we just simply take our information and plug it where it needs to be. V sub F is 0. Always put the final first. Even if it's 0, there's a reason. You're going to see in a moment why we do it this way. And then the initial is 10 meters per second. And we're going to divide by 20 seconds. Sorry, I'm getting them confused with the ones from above. Okay, there we go. All right. So now 0 minus 10 leaves us with negative 10 meters per second. Okay? Divided by 20 seconds. The zeros cancel out. We're left with 1/2, which is the same thing as negative 0.5. Remember, 1/2 is the same thing as 0.5, and that's going to be meters per second squared. Now, why the negative? Remember, we're starting with a velocity of 10 meters per second. And for every second we slow down, we're going to subtract 0.5 meter per second from this. Okay? And so that's why it takes 20 of these to get this from 10 to 0. You're going to subtract the increment from your speed every second for 20 seconds, and then you'll be stopped. All right? So when the negative is on there, that means, especially if the velocity is positive, that means you're going to slow down. That's why it's so important to always use final minus initial, even if the final is smaller. If you don't, you won't get the right sign for the direction on your acceleration. Okay? Because the negative means you're going to be slowing down, not speeding up. Okay? All right. Now, after knowing that, you should be able to do these 5 problems using our 3 steps. Please remember, first, identify the given information and what you're looking for. Chuck it into the formula, and then use your calculator and come up with an answer with the correct units for acceleration. Remember, sometimes there may be inferred information. If it says the object is initially at rest, like it did here where he was stopped at the light, that means the initial velocity is 0. Now, you won't always have that, but sometimes you do, so be aware of that. Sometimes the object comes to a stop. That means the final velocity is 0. Be aware of that. Not all objects do, but you should notice it when it says it and understand that that is a numerical piece of information given in words instead of numbers. Okay? All right. Have fun with this. If you do get stuck, just message me and I'll be happy to help. Thanks. Bye-bye.